Hi guys. So now that we have set up GitHub Auth, now it makes sense for us to design the database schema of our application. The database schema is pretty simple. We have two tables, chats and questions. We do not have a users table because Supabase automatically creates a users table that is a read-only table and managed directly by Supabase. So we have a chats table in which we have properties like the primary key, the ID, the public URL of the file they are trying to upload to chat with it, the created at and updated at dates, also the user ID. So the user ID points to the user instance in the users table managed by Supabase, and each chat can have many questions. So it makes sense to create another table called questions, in which we have a chat ID, which is a reference to the chats table, and we have query, which is the user's question, and the response, which is the LLM generated answer to that question. And we also have a created at date for this question. One thing that is surprising, if you haven't noticed already, is that all of our date fields are actually integers, big integers, big ints. And we're gonna get into this later on, why we choose integers, but we typically use them because they're easy to handle and there isn't any time zone allocated to it. Now to create these tables, I'm going to use the SQL editor directly in Supabase. So for that, you're going to go into the SQL editor. Now, if you're working in a team, I would encourage you to use something like migrations, database migrations, or the branching feature of Supabase, because it will keep your team aware of all the changes you guys are making to the database. But for this simple project, we are going to use the SQL editor directly. So the first thing we are going to do is we are going to create the extension to enable us to use UUIDs in Postgres. UUID is a very unique string, basically, to uniquely identify any object. So, and the chances of conflict is pretty rare. UUIDs are primarily used as primary keys for rows, and the reason they are used extensively is that they are super unique and it is rarely possible for you to conflict two IDs. So the first table we are going to create is the chats table. I usually like to add if not exists, because if I'm to rerun this query, it wouldn't error out, and if it exists, it would just ignore the query. Also, one thing I really like is to name my tables with the plural of what I'm describing. So instead of chat, I use chats. It is just my personal preference, but I don't think that there's any strict rule to it. First, we are going to define the primary key, which is a UUID, and we're also going to generate one by default. So anytime you insert an entry into this, you do not have to specifically generate a UUID, and Postgres would automatically generate it for you and add it to the row. We have to specify that this is the primary key. Other than that, we have the title, which is a varchar of 255 characters, the user ID, which is a reference to the auth table that is managed by Supabase. And we are going to use onDelete cascade. What this means that if we delete the user to which this chat belongs to, it will also delete the chat from the chats table. So it doesn't make sense for a chat to exist if the user has been deleted, right? So what we want to do is that the user deletes their account for some reason, the chat also gets deleted. We're not going to implement the feature of deleting users. This is what most people do, where if the existence of one entity relies totally on the existence of another, deleting one should also delete the other. So it doesn't make sense for a user to have a chat if the user doesn't exist. So we just delete the chat as well. We have the public URL of the PDF file that the user has uploaded to the chat. And then we have the created at big int not null. And we're going to give this a default value of the epoch in milliseconds. And the way to get that is using the extract function. We extract epoch from the current timestamp, which is a variable in Postgres, and we multiply that by 1000. And we cast this whole default value into a big int. We do the same thing for updated at. Now you can keep updated at as null. I typically like to use updated at as the same as created at when we insert an entry, and on updates the updated at is different than created at, so that just shows us that the entry has been updated. We also want to enable row level security for this table, and what this would technically do is that only users that are authenticated are able to access entries from this table. So this line enables row level security for the chats table, but now no one can access the rows of this table. We need to have a condition on the basis of which a user can actually access this table. And how we are going to do that is we are going to enable each operation, such as insert, updates, reads, to be accessible by different conditions. And what I mean by that is that inserts can only be possible for users that are authenticated to our application. So let's create a policy to allow only authenticated users to be able to insert to this table. For that, I'm going to create a policy, enable authenticated inserts, user insert, and I'm going to specify the table on public is basically the schema, public.chats, which is the table name, as permissive for insert to authenticated, and this means that it is only possible for authenticated users. Now let's create a read policy, which means that only the user who created the chat is able to view that chat. Owner read access, I'm going to name it owner read access. The table remains the same. The condition we are going to do is basically we are going to run a subquery over here, in which we match the currently authenticated user with the user ID from the chats table that we have described over here. So the method to get the user ID of who is executing this query is using select auth.uid as UID, and we can check if it is equal to the user ID that comes from this table. So what this policy does is that every time someone's performing some sort of a select statement on this table on public.chats, Supabase uses this policy to ensure that it is only possible to execute that if the user who's trying to execute this query is the same as the user who created this chat. So now I'm going to run this query and create a chats table and enable row level security with the two policies that we have created for this table. Oh, so apparently there is an error in which we have to replace this with double quotes for this to work. And now let's hit run. Yeah, there's another syntax error in which we apparently forgot a comma over here, which would probably be over here. And we forgot another semicolon over here. God, too many syntax errors. And we also had to fix the spelling of security. And we have to fix varchart into varchar. Sorry, I'm making a lot of mistakes. And voila, now we have the chats table created. We can take a look at it, and you can see we have the ID, title, user ID, created at and updated at, and the public URL to the file that we are going to later upload and get the public URL too. So now let's do something similar and create the questions table. I'm going to speed run this a little bit because I've already created the chats table and explained pretty much everything over there, and questions table is pretty much similar to that. So for the ID, I'm going to capture this. We're going to store chat ID, which again is a reference to the chats table. And again, if the chat is deleted, we do not want to store the questions, and we also want to delete the questions for that chat. So the query is the question the user asks, and the response is the LLM generated response. So I'm going to make this as a text because I do not want to specify any limit to how long this should be. And again, we are going to add created at, which is a big int. I'm going to enable row level security for this table. Honor only insert access. Let's specify the table, which is public dot questions as permissive. For insert, specifying the operation we need to create this policy for, and we need to provide it to authenticated users. So that just makes sure that the user is authenticated and we can access their user ID by running auth.uid. So allowing only honor insert access on public.questions is kind of difficult because we do not store the user ID in the questions table. The user's ID is stored implicitly through the chat relationship. So basically, each question belongs to a chat where a chat is belonging to a user. So to actually get the user ID, we need to be able to run a subquery on the chats table. And how we can do that is we can say select auth.uid as UID in, and we are going to run a subquery which is select chats.userid from chats, where chats.userid is equal to questions.chatid. Actually, this should be chats.id equals questions.chatid. So what this does is that this subquery fetches all the user IDs for which the chat ID is the same as the chat ID of this question. So what this query does is that it returns all the user IDs from the chats table for which the user is the same as the user that is trying to create this question. So this array of IDs will contain the current user's ID, and if it contains, then we can say that okay, this user is trying to create a question in a chat that belongs to them. So we can permit this action. Now, by the same logic, we can also create a read policy. So I'm going to copy this and I'm going to name it honor only read access, which should remove all this. So what this policy would do is that it will enable only users that belong to the chat, which is the creator of the chat, can actually read the questions of this chat as well. So RLS is kind of difficult to wrap your head around, but this is really important to implement because this allows you to be not so strict when you're writing your APIs. So you could imagine that if you're trying to have some sort of a role-based access control within your application, then that is going to involve a lot of like either middleware code or a lot of repetitive code in which you're trying to make sure that the user that is trying to access the resource or trying to perform an action on a resource is actually authenticated and authorized to do so. But with RLS, you do all of that on the data layer, and you don't have to worry about it on the API layer, which is, I think, always sweet because your API layer is pretty clean. Now, if you want to test row level security, you can do that by executing queries as a role. So this is the Postgres role, which has the maximum amount of privileges. So it acts as an admin when you are executing roles. The anonymous role is when you're not authenticated. It acts as an unauthenticated users. And with the authenticated role, you can impersonate a user, and then you'll only be allowed to perform actions or access resources that this impersonated user can access. We're not going to do this right now because we are going to focus on creating the application. So let's run these statements and create the questions table and enable row level security for it. So as usual, we are facing some errors. And the first error is related to authenticated. I think in insert, we need to add with check. When we are doing it for read operations, we need to use using statement over here. Let's try to run this now. But I think we're also going to fail on semicolons over here. So let's add those as well. And run. Yeah, I think since we copied it, we accidentally had for insert over here. We're going to remove that. We're also going to remove as permissive because we don't need that when we are specifying a read policy. So now I think we can execute this. And yeah, so we created the questions table. We created two policies for RLS, which are allowing only the owner to insert a question to this chat and only allow the owner to read questions from this chat. Now, if we go to the database, we can see that the questions table is created and we have all the necessary columns we need. And if you want to take a look at the policies, you can go to the policies and you can see that for the chats table, we have an insert and a read access. And for the question, we have insert and read access as well. If you look over here, you can also edit your policy over here. We didn't use the UI to create policies, but you could also do that from here. When you go to create policy, you can define the name, you can define the table you want to enable it for, and you can define the operations you want to allow. The target roles basically include anonymous or authenticated, for example, and you can provide a Boolean statement over here, which would enable only those users that pass the Boolean check to be able to access the underlying resource. There are also some templates that Supabase provides. So when I click on these, it automatically changes the settings and adds it to the policy. But we're not going to use this because we have already created our RLS policies, and I think we're good to go. So in this video, we wrote some SQL to basically create the different tables we have and also enable row level security and create policies on the tables. And now we are in a position that we can actually access these tables using the Supabase CLI. So in the next video, we are going to go to our application and use the Supabase clients that we created in the last video to be able to interact with this database. And we are also going to generate types for the database, so we can have type safety on a TypeScript level that defines which tables we have created and what columns exist on each table. So in the next video, we are going to be working mainly on the UI side of things. We are going to be adding the home page, which will show all the chats we have opened. Right now we have none, but we can start a new chat in which we have a form to upload a PDF file, to add a query, the initial query, and start a chat. And we are also going to be adding the logout functionality and everything related to the functionality of the application and the UI side of things. So if you're excited, make sure to like and subscribe, and see you on the next one. Peace.